Okay, we're going to continue our Chapter 10 review looking at question number 9. Question 9 says that we have an election ballot that's asking voters to select 4 city commissioners from a group of 14 candidates. And how many ways can this be done? So city commissioners all have the same title. They're just commissioners. So because they all have the same title, it's not going to matter who's chosen for city commissioner first, second, third, or fourth. So in this case, the order is not going to matter. So because we're choosing 4 out of 14 people and the order doesn't matter, we're going to be using a combination to do this. So we're going to take our total number of candidates and we're going to choose 4 of them. And we're just going to go ahead and type that in the calculator to find our answer. So we have 14, choose 4. Our total answer is actually going to be 1,001. 1,001 different ways for these people to be chosen in this election. That's it for question 9. Let's move on to question 10. Question 10 says that we have the opportunity to pick a license plate for our first car. It has to be 6 characters long. We have to have 3 letters followed by 3 numbers. So 3 letters, and we have to follow that up with 3 numbers. The letters, it says, can be any character from the alphabet except O, Q, and V. So we know that there are 26 letters in the alphabet, and we have 3 that we can't choose, which means we only have 23 options for our letters, and I'm just going to write that off to the side to remind myself that I have fewer options than normal. Then it says that the first number that I pick can't be 0. So if we think about how many options for numbers we have the digits 1 through 9 and the number 0. So normally we have 10 options, but in this case it can't be the number 0 for the first number we pick. So we're only going to have 9 options for our first number, and then we'll figure out how to go from there. So for the letters that we pick, we know that we have 23 options. There's nothing in this question that says that we can't repeat ourselves, and that's going to be important because I know I'm going to have 23 options for the first letter that I pick, but it doesn't say anywhere here that I can't repeat myself, so I don't actually take away anything for my next option, because if I pick A here and I want to pick it again, there's nothing stopping me. So I actually have 23 options for my second choice and 23 options for my third choice as well. Now for the numbers, I just said that I can't pick the number 0 for my first digit here, so I know I only have 9 options for my first number. But for my second number, there are no restrictions. It just says that the first one can't be 0, but my second number could be anything from 1 through 9 and including 0. So I actually have 10 options for my second number, and I have 10 options for my third number because there's nothing restricting that one either. So in this case, I have 23 options for each of my first letters, and I have 9 options for my first number, and 10 for my second number, and 10 for my third number. So using the fundamental counting theorem, we're just going to go ahead and take all these options and multiply them together because they're all going to be happening at the same time. And when I type that into my calculator, 23 times 23 times 23 times 9 times 10 times 10, my final answer is going to be very, very large. It's going to be 10,950,300 options for my license plate. Very, very unique. Now we're going to move on to question 11. For question 11, I'm going to be concerning myself with arrangements containing 5 letters. Let's get a new paper here. Arrangements containing 5 letters, which are formed from the word kingdom. Now, kingdom is a 7-letter word. I'm just going to write 7 letters just to remind myself, so I don't have to sit here and count the letters over and over again. So the first question here, part I, is asking us to find the number of 5-letter arrangements that start with the letter M. So they have to be 5 letters long, and the first letter has to be M. So how many M's do I have to choose from? It looks like in the word kingdom, there's only 1 M, so I only have 1 choice for my first letter. Now for the rest of my 4 letters, I have to arrange these letters, but I can't repeat myself. I've already chosen the letter M, so I only have 6 letters remaining to choose from here. And the order does matter. I'm arranging these letters, so the arrangement means that the order matters. So I'm going to use a permutation, and I have 6 letters remaining after I choose the letter M, but I only want 4 of them. So I'm actually going to end up doing 6p4 times the 1 option that I have for my first letter. So if I type 6p4 into my calculator, my answer is going to be 360 ways to arrange these letters, because when I multiply this by 1, it doesn't change. Now, for part 2 of this question, it's asking me for the total number of 5-letter arrangements with no restrictions. So instead of having to choose M for my first letter, I can choose whatever letters I want to arrange. Again, order still matters because I'm arranging these numbers. So I have 5 numbers that I want to arrange. And because order matters, we're using a permutation. And the total number of letters that I'm starting with is the original 7 letters of this word. So to solve number 2, we need to do 7p5. 7. We're going to type this in the calculator. We're going to type this in the calculator correctly. Maybe on the third try. Third try is a charm. There we go. 7p5. And the total number of permutations for that is actually going to be 2,520 permutations. Now for part C, it's asking us to find the number of 5-letter arrangements that begin with the letter K and end with the letter N. So for part 3 here, I have 1, 2, 3, 4, 5 letters. My first letter has to be K. My last letter has to be N. And I'm still arranging these, so I'm still going to use a permutation. The number of options that I have for my first letter is just 1. I only have 1 K in the word kingdom, so I only have 1 option for the first letter of this new arrangement. And again, I only have 1 N in the word kingdom as well, so I'm going to have only 1 option for my last letter here too. So I'm going to be multiplying these by whatever options I have to arrange these middle 3 letters. Now once I choose my K and my N, I originally started with 7 letters. I've chosen 2 of them already, so I only have 5 options left to arrange here, and I only have 3 spots to fit them into. So I'm actually going to do 5p3 in order to arrange the middle letters here. Because I'm only going to be multiplying them by 1 and by 1 again, I can actually just type 5p3 into my calculator and it'll give me my final answer, which is 60. 60 ways to arrange these numbers. We're going to go ahead and pick up with question 12 in the next video.